Hi guys. Let's talk about section 9.1. I hope you're having a wonderful time back at school. You should be watching this video at your house or after school, and then in class this week I want you to work on the actual homework. So you're going to spend your class time working on MathXL, and then from your house you will, in the evenings, you will watch the 3 videos that I'm going to load up for this week, okay? Section 9.1, 9.2, and 9.3. Okay, these homeworks you do need to work on. They are going to be due. We're not going to take the Chapter 9 test until after I get back. Okay, so let's look through these notes. In your notebook, you've got these notes filled out and not filled out. Okay, so you should feel free if you want while you're watching this video. You can pull it up. You can find it on YouTube if you want. Okay, pull it up on your TV, okay, or on your computer, and then you can sit and work these notes separately. Okay, maybe on your iPad or whatever, okay? But you have both versions just in case, okay? This first one says the graph shows seasonal average 8-hour ozone concentrations in 53 urban areas during the summer months from 1997 to 2005, okay? What is the first year after 2002 where the trend unadjusted for weather, so if we're looking at this, that's the blue one, okay, shows a higher ozone level than the trend adjusted for weather. So we want after 2002. So 2002 is about right here, okay? So we're talking about the first time where the blue one jumps above the red one, which is about, maybe I should make my arrow point right there, okay? You see right there, the blue one jumps above the red one, okay? Which looks actually like right after 2002. So the first year where the blue, unadjusted for weather, is above the red, adjusted for weather, would be the year 2003. Okay? The vast majority of these questions in this section you're going to be able to use PolySmelt for, so it should be a really good section, okay? If you remember, okay, when we have systems of equations, that's 2 equations with 2 variables, we had lots of different ways that we could solve these. We had substitution, we had elimination. My favorite is elimination, and that's where you're going to look at your system and you're going to try to eliminate one of the variables. So what I would probably do if it were me is multiply this second equation by 2 so that it now looks like negative 2x plus 2y equals 18. And then I add the 2 equations together. So notice that my like terms are in line, okay? 2x minus 2x is nothing. 5y and another 2y gives me 7y's. Negative 4 plus 18 is 14. I'm going to divide both sides. Yikes. Yikes. I'm going to divide both sides by 7. And I get y equals 2. Okay, from there I can plug this back into any of the equations, actually either of the 2 original equations that I want. So I'll plug it back into the first one, 2x plus 5 times 2, because remember we just found y equals 2, equals negative 4. So if I subtract the 10 from both sides, I get 2x equals negative 14, and divide by 2, x equals negative 7. So my ordered pair solution would be negative 7, comma 2. If you use PolySmelt, you're going to get exactly the same answer. I don't care which you use. If you want to do it by hand, that's lovely. If you want to use PolySmelt, that's also lovely. The danger when you use PolySmelt is you have to be careful. Your equations have to be in order. So if you look at this second one, 2x minus y equals negative 7, is lovely. The second one, not so much. We have to rearrange this, right? 2x minus y equals negative 7 is lovely, okay? But this one we want to make negative x plus 4y equals 7. So you want to make your 2 equations, okay, sort of line up like this, okay? Then if you want to use PolySmelt, you certainly can. Okay, so you'll pull up PolySmelt, which looks like this, okay? And instead of root finder, which is what we have used, now we want simultaneous equation solver, so the second thing. And it's going to ask you how many equations do you have and how many unknowns. I have 2 equations, right? Here's an equation, and 2 unknowns, that means variables, x and y, okay? So I want fractions, so I want next, so I'm going to hit this button up here, okay? And then system matrix. This asks me to type in, okay, what my coefficients are. So on the first line, my first equation, 2, -1, -7. So 2, enter, -1, -7. And then I'm going to put in the coefficients that I have on the next line, which were -1, 4, and +7. So this is why it's so important that you make sure that you get your equations rearranged, because you're going to put the numbers in the wrong place. And I hit solve and I get my solution. So my ordered pair answer then is -3, 1. So -3, 1 would be the answer that I would type in. Okay? The next one we can do exactly the same way, all right? And if you've already got Polysmelt open, the kind of cool thing you can do is see down here where it says System, which is the third button. So I'll hit Zoom. All I get to do then is retype in the coefficients, type in my new coefficients, because I'm still using the same size system, 2 equations, 2 unknowns. So 2, -4, 38, and 5, 3, 30. And so my answer then is 9, -5. Easy peasy, right? What happens if you have fractions? Is it the end of the world? No. They are saying clear the denominators. Well, okay, I can clear the denominators. Do I have to? Not really. Polysmelt can handle fractions, okay? So I can just type in 7/2. Might change it to a decimal, totally fine. 7/3, 119/6. And then in my next equation I have 1/4, 1/3, and 19/12. And when I hit solve, it gives me, okay, yikes, it gave me the wrong answer. So what did I do wrong? Let's go back here and look. I think that I must have typed something in wrong, because I don't believe that's what we were supposed to get. Let's see, 7/3, 119/6. Okay, I think that's where I made my mistake. Let's see. Oh, that looks so much better. 5, 1. Okay, so 5, 1. In the next one, okay, again, can you use Polysmelt? Absolutely you can. Do you have to be a little bit careful? Absolutely you do. What do you have to be careful about? Well, to type this, or to rewrite this so that I can use Polysmelt, I need to add the 2 in the first equation, and I need to add the 13 in the second equation. Okay, so it reads 2x minus 2y equals 2, and x minus y equals 13. Okay, so let's try typing this in. And again, I'm still dealing with a 2 by 2 system, 2 equations, 2 unknowns. Okay, so let's see, 2, -2, 2. Let's make sure I type them in right this time. 2, -2, 2. And the second line was 1, -1, and 13. Oh no, no solution found. How is this possible? Well, think about what this means, okay? The solution is the empty set, no solution, right? So you really have 3 sort of possibilities when you're dealing with systems of equations, okay? Because these are really 2 lines. Each of these equations represents a line. So if there's no, the solution is when the 2 lines intersect. If the lines never intersect, that means they're parallel, and you're never going to have a solution, okay? The next one is another kind of weird looking one, okay? When we use Polysmelt, and I copied what it looks like in here for you. When we use Polysmelt, we get sort of this weird answer, this solution set that looks kind of funny like this, okay? And you got to remember a couple of things. First of all, when you see x1, that's really x, okay? And when you see x2, that's really y. We're using the letters x and y. So x2 is really y, this is really y, okay? So our solutions are 3/5 minus 6/5 y, comma y. Okay, and that means that this system has infinitely many solutions. So 3 possibilities. You can have a lovely solution like 5, 1. You can have no solution at all, or you can have infinitely many solutions. Okay, this one happens to have infinitely many. The next one, very similar. The only difference is you're going to pick 3 equations and 3 unknowns. This one has one lovely solution that happens to be -2, 3, 0, and I'll let you check that for yourselves. Okay. The next one, also 3 equations and 3 unknowns. See how we have 3 letters there, x, y, and z? You got to be careful. Be sure that you add the 5, add the 4, and add the 16. Okay, so that last column that you type into Polysmelt should have a +5, a +4, and a +16. And I'll let you do this one and check your answer. You should get 9/7, -1, 34/21. Okay? This next one is very weird. It says, let P equal 1/x, Q equal 1/y, solve for P and Q, then find x and y. How unusual. So what they're saying is, okay, this 1/x, which is really what we have here, this 3/x is 3 times 1/x. We're going to let that be P. Okay, so this equation now reads 3P, and 1/y, we see that kind of sort of here, right? 2/y would be 2 times 1/y. So that would be 2Q equals 13/6. And same thing again, 4/x is really 4 times 1/x. 5/y is 5 times 1/y, and that's going to equal 1/3. Okay, if I put this system into Polysmelt, I get P equals 1/2 and Q equals 1/3, which is a perfectly lovely answer, but I didn't start with P and Q. I don't care what P and Q are, I care what x and y are. So let's regroup. P, remember, was 1/x, and we're saying that's 1/2. And Q was 1/y, and we're saying that that's 1/3. Okay, so that means that x equals 2, y equals 3. So my ordered pair solution would be 2, 3. Okay. The next one, we have a word problem, applications, how fun. The sum of 2 numbers is 48, and the difference is 6. The 2 numbers, what are we going to call them? How about x and y? The sum, what does that mean? It means add them together. Difference of the same 2 numbers, that means subtract them, equals 6. This gives us a lovely, lovely system of equations. Can we Polysmelt it? Yes, absolutely you can. And you should get x equals 27 and y equals 21. Okay, when you put that in Polysmelt. One last word problem. Perimeter of a triangle is 62. The longest side is 12 inches longer than the medium side, and the medium side is 7 inches more than the shortest side. Okay, so they've labeled for us the shortest side. Do you see that? It's x. Okay, the medium side, they're saying, is 7 inches more than the shortest side. So that would be x plus 7. Okay, the long side is 12 more than the medium. So if the medium side is x plus 7, then the long side is even 12 more than that, which would be x plus 19. Okay, and then what do they tell us? The perimeter is 62. So we're going to add up all 3 of these sides. X plus 19 plus x plus 7 equals 62. So putting our like terms together, we have 3 x's plus 26 equals 62. Subtract 26 from both sides and divide. X equals 12. So the shortest side is 12. The medium, which was 7 more than that, is 19. The longest, which was 12 more than the medium, comes in at 31. And you can check your work. Add up 31 and 19 and 12, and you'll get 62. Okay? So now wait for class tomorrow and do section 9.1 during class. See you soon.